Honey, a storm is coming.
Oh no, the power's about to go out. Turn on the news.
The substation will soon go out. If you're still listening, it's an assembly because...
We made it here!
We're here to help with the power.
Who are you?
We're time travelers from 2080. The current transmission poles are ineffective because they don't store electricity. We've come with a better solution.
Our solution
Hydroelectric U
is portable and storable. The electricity may be used any time. This is much more effective than the transmission poles being used in your time period.
Our team was tasked with coming up with a better energy future. We looked at several problems and solutions such as solar power, biomass energy, nuclear, and of course methane. We debated on what the biggest problems were. In the end, we voted on what the group thought would be the best problem to solve. We decided to focus on the problem of energy storage.
Since our school is a green school, our principal, David Kupalo, took us on the roof to tour the solar panels. This helped us gather information about energy storage.
The school engineer, Mr. Lee, works on the solar panels on the roof. He explained that the solar energy created is sent to a local electric company where it's distributed to homes and businesses in the community. We learned that the energy transmits through poles with high voltage, however none of this energy is ever stored.
And when storms arise, if a transmission pole or substation is knocked out, all the power moving forward shorts out, leaving many homes and businesses without power. It can be very costly to replace or repair, as well as time-consuming. Our team created a portable storage bank,
Hydroelectric U
that bypasses the power company and stores energy for personal use.
Most batteries are a one-time use. Americans throw away 3 billion batteries each year on average. These batteries contain toxic materials, and when added to landfills, those materials enter the groundwater system, propagating through the food chain.
So we should be using renewable energy instead of just storable energy?
We should be generating energy that produces no greenhouse gas emissions from fossil fuels.
We've created renewable and solid-state batteries that won't leach into landfills and use hydro energy to charge them.
Hydroelectric U
Why hydro energy?
The majority of the Earth's surface is water covered.
After researching atmospheric generators, water wheels, and turbines, we decided to focus on hydroelectricity.
Hydroelectric U
We began with better water systems. After researching, we discovered that we didn't have enough pressure to create enough energy, so we started thinking of other water sources.
Letting a faucet run for 5 minutes can waste 10 gallons of water, which can power a 60-watt light bulb for 18 hours. With this information, we decided to record the time the school sinks ran at an average of 18 to 20 seconds per use.
We created a survey to find the number of times the faucets are used. The survey told us that the sinks run 43,920 seconds a day.
Wow, that's a lot!
We decided to use a generator to create energy for the water in the faucet. We first added a generator inside the pipes, then decided it would be more portable and easier to put it on the faucet instead. So we created an attachment for our faucet. One member came up with the idea to attach a funnel with a Christmas tree light stand. Using this type of attachment, it's easy to adapt to many different faucets. We then added a vortex inside of the tunnel to let the water flow quicker and create energy faster.
Then we connected the generator to the battery that we created.
Tell me about your battery.
We experimented by creating batteries using charcoal and an ash combo and also polymer clay. We decided to use the polymer clay, which when used a certain way using a conductor can pull 8.5 volts.
To make our storage more portable, it's in a cooler so it'll be easily transported. This way,
Hydroelectric U
can be used in a cycle. We'll never run out of electricity as these things are charged and ready to go.
The funnel is attached to the faucet. When the water is turned on, it runs through the funnel, through the generator attached to our solid-state battery in the cooler, where the energy is stored. The cooler can be easily moved around our school or home and connects to many different devices using the attached USB whenever anything needs to be charged. We can alternate them out when devices need to be charged.
This is our kit.
Everything except the faucet attachment can be purchased on their own since they've already been created.
Or hydroelectric
Electric U
can be customized to fit your needs. Our kit makes it possible to recreate what we made to use in homes and businesses.
What's the future like with hydroelectric
Trick U
The future, our future, has cheap, renewable, and solid-state energy. We've been able to survive through very harsh storms with electricity. We don't need to rely on the power company and their high costs either, and you will be able to as well with this information.
Oh no, the substations are.
Oh no, we lost power, but I wouldn't do this.
When the storm is over, we gotta make this work here.
Hydroelectric U.
Solves many problems.
It's low cost, portable, safe, and renewable.
It's creating a better energy future for everyone.
Thanks for listening to our presentation. Any questions?
This is our prototype for our model. If you have any questions about it,
Are you able to like bring it here and kind of show us how it works?
Okay.
you want to explain all this?
So, this is the faucet, and it wouldn't actually be on the cooler, it would be in a sink. And then we created this, me and Grant created this vortex funnel on Tinkercad, and with this Christmas tree-like stand that attaches to this, and then the water will go through, and then go through this, it'll gain electricity going through the vortex, and generate electricity when it goes through the generator that
And then the wires will come down through the plug in the back where you would usually let the water out of your cooler. And then in here we would have a battery. This is just a small scale of it, but so it would go into that and hold those 8.5 volts.
this is the battery pack. So
And the outputs are lightning cable,
For your phone.
USB-C,
And
micro USB, and this would be a USB, but we couldn't find any ports.
What made you choose those particular outputs?
They can charge a lot of different devices.
And they're usually
common.
the most common.
Yeah.
So when people lose power, you think the most important thing they need is access to their phone?
Yeah, to call people.
Phones, radios.
Yeah. Radios,
And to
all
add
that stuff.
on, we did share this project with people in our school and other schools around us.
Could you potentially take this and use another type of cable, say like a regular, two plug, negative, positive?
Yeah.
Yeah, that's why
You would
we
need a
have
bigger
the-
battery.
We would also
And
have
again,
the USB here that you can
this-
plug in your own plug that you have.
As we said in our skit, this is very adjustable. Since we use a lot of things like Tinkercad where it's just 3D printing, you can change the size and how it works very easily.
Can you tell us more about the Christmas tree design that you mentioned a couple times? What made you decide to go with that
So,
design and how does it work?
I work on a Christmas tree farm
Okay.
in the winter. And so I thought of this randomly. And so if you think about it, you screw in the sides to hold in your Christmas tree.
Mhm.
What if we were to be able to use that to screw in and hold in our attachment?
Now, the reason that we have the Velcro and not just the Christmas tree,
To keep it stabilized.
they are too close together, so they don't really work well.
Because again, this is just a model.
Yeah, this is just a prototype, so that's why the Velcro is there in case you want it.
And because it's a cooler, it's easily portable because you can just hold it back and move it around.
Since our school has so many bathrooms and it's so big, we would be able to just pretty much cart this around the school and charge it whenever it runs out or whenever you want to charge it.
And also in a more of a consumer model, this cable would be hidden so that it wouldn't be, ugly in your bathroom, or it wouldn't be exposed to the water that's coming down into your sink.
And again, you wouldn't have to use a cooler, just some way to mobilize this to move it around.
Like a portable storage bay.
Anything you guys want to add?
Can you guys scale this on, say, like a dam?
You
Well-
could, it would have to be a bigger scale and more permanent, of course.
Yes.
Again,
Yes.
you could make a more permanent version of this without it.
We also originally thought that you could make a pipe version where it was hidden inside of your pipes, and that would be more of a permanent thing.
We didn't originally use the cooler with this type. We were originally just going to put the cooler with what he said inside the pipes. We were just going to charge a little battery pack, but then we decided it would
Be
More
more
portable.
be more effective.
Any questions?
Absolutely, yes. I think you that mentioned that you shared your project with some people. Who specifically did you share it with, and what kind of feedback did you get?
So we had people come to our school and fly drones and teach kids how to fly drones. So we were thinking about more of electricity side, and they did give us some feedback, like to make it more portable and to make it different scales for different occasions.
We shared it with the local schools near us. So since we're in Myrtle Beach, we shared it with Burgess Elementary, St. James Elementary.
In St. James Middle.
One person. Oh, go ahead, Charlie.
As I was going to say, also, Kristen and Brooke made a Zoom meeting with an electrician and asked questions, and they got feedback.
It was Mr. Hubbard, an electrician.
And see, for future improvements, we were thinking about putting a voltage meter on this. That way you could just read easily how much voltage it's putting out to see if it is still good or not.
So, we showed it to some. I showed it to some people today. And one of the things that we got. So whenever water goes in the water tower, it takes pumps, right, and that uses electricity. This is kind of restoring that electricity that you use to pump it into this, which you get electricity out of it, so you're not wasting electricity.
And the whole point of having the vortex funnel, having it start so wide out, it would circle around, giving you more electricity as it went around and got slower and thinner.
And it could be used in more commercial uses. I mean, if it would to be scaled up, you could use it in places like water towers where you lose energy.
Any more questions?
I just noticed in your little packet you gave us there, is this a picture of you guys? Is this you and your
Yes.
team?
Yes.
What's
Yes.
going on here? What,
So, I wasn't there for that moment because I joined late, but this is the roof, and these are.
your school.
That's not the
Yeah.
roof. That's the
Well,
attic.
this is the attic, yes,
Yeah.
right below the
That's
roof.
sort of like right below the solar panels where they store everything.
Okay, so you took a field trip basically to the school where you actually saw this kind of in action, and that's where
Pretty
you got
much.
Yeah,
inspiration.
they
That's where we
use
saw the
geothermal to make the water to pump the water here. They use geothermal, so they tell us a little bit about that.
Who's the person?
That is David Kuplo, our school principal.
And he's an expert in knowing about these things because you're a green school? Is that?
Him and Mr.
Yes.
Wu.
Okay,
He said that we are the most green school in the country.
very neat. And then I just remembered that you have what's going on here, so is there anything you wanna add on to
So
what you
these
showed
were
us?
pretty much our different models. Go ahead, Charlie.
So originally we were gonna attach this to the faucet, but then we realized all sinks are different and it
It
didn't
might not
really work well.
Yeah, it did work well with
And then I created this, which is a vortex funnel, but when it 3D printed, it kind of messed up, as you can see. So,
yeah, it didn't go through all the way.
and we also tested like this, when if you
Just
were
a
to
plain
put
old
it,
funnel.
a plain old funnel, yeah, and if you put it in the water, like it would fill up and then overflow. So then we were trying to figure out ways to prevent that,
And one
and
thing
then we
hard
started building this.
was
This is what this is. That's what this is.
you.
But this was
One
most
really
regular.
hard part about getting these 3D models was you had to find out each thread on the screw and find out each distance away from it. That way it would be able to screw off.
Yeah,
That
that was
that actually is screwed in there?
Yes.
Because
You
oh
can
my
actually
gosh,
unthread it.
That's impressive, guys.
Same with the screws, where obviously 3D printing is not perfect. So some screws are a little bit tighter than others, but
Wow.
after a tiny bit of wear, using it daily, it would adjust to fit it.
So which of these was your first solution? Like, was this was the first one?
Yep.
Yes. And then
And so you just kind
I
of
built
gradually
this.
improved until you got to that end product?
This
Yes.
is the same thing that's up there.
Okay.
It's
Except
just-
this
the
one, this
problem with
didn't work because
it
it
was
wasn't.
wobbling.
It was wobbly. And this is the inside of that bottom piece. This is that bottom piece. Plus this one was
So
too
then our
strong.
final model, we came out with this. It ran through smooth. Another problem we had was when the water would come through, because the sink's pressure was so high, it would go through and it would overfill before that 20 seconds. And so we had to be able to find some way. And so in our original model, I'm pretty sure, yeah, there was no hole in the middle. Whereas you see with this one, there was a slight hole.
Yeah, this one, yeah, these two are the same. This one also the water shut out of these. Yeah.
All right, guys, we have heard a lot about your project. You have so many cool things to share, but we need to move on to robot design.
All
So
right.
can we, do you have anything prepared to share with us about your
Yes.
robot?
Yes.
Okay.
Very much.
Grabby Gary.
His
Oh,
name is Grabby
Yes,
Gary.
yes, we decided
Gary,
1
okay.
week ago to name him Grabby
We
Gary.
had Fred earlier from another team, so it's interesting. Maybe Gary and Fred can meet each other.
So this is our robot. And so our first model of a robot, we had one motor arm. Oh yeah.
We have a picture on our board right here.
And it's very unstable.
It only had one thing where it was 1 year.
So
And
if
so-
you see on this one, it only has one arm. I mean 4 arms, sorry. But our old robot, it was only one of these centered in the middle. So it wasn't as stable, and as we started to add more attachments to it, it became very wobbly and inconsistent.
And another thing is this one, it can move straight up for.
Yeah, Yeah, because the other one, it was just
It
one
would
arm, so it
go
would
back.
just.
It had 1 point of articulation instead of 4. And then we have, for this one, we were able to add 2 attachments, where one is our pusher attachment, where it can move down to grab stuff and pull stuff.
Because
It
on
can-
the windmill, one of them, you can collect it, so it also helps having a basket
it also,
type of thing.
yeah, it also has a basket, so you can pull stuff, you can push stuff, and you can knock stuff out of the way by turning. And then we also have this one, where there's 3 points, which these 2 are for the power plant, and this one is for the hydro plant. And where we can just stick them in here, and it can either lift up or push down something.
And this would be off.
Yeah.
This would be off for
One
them.
attachment.
And then we can also just use bare yellow thing to push
Because when
stuff.
you do the model one,
We just use it to just push it.
And to find this robot, we did a lot of research.
Because we had an old robot, and with that old robot, since it wasn't working, we had to find some way to change it. So we came up with this robot about halfway on the way.
How did you come up with this one?
We looked at other
looked at
ideas
other
models, online, and we
and we
tried
sort of just-
our best to put them together and revise them and improve on it.
Any questions?
Yeah, so you have just a couple of attachments. How many missions are you looking to accomplish today?
So we have 8 different presets, or no, we have 7 different presets on here. We are first doing the rechargeable battery, then we do the TV, the windmill.
And the windmill. Those are
Then
the
we-
same mission?
Yeah.
same
Awesome.
preset.
Then we have to do the power plant, the project model, the oil rig, the energy basket, the hydro plant, and the solar farm.
And the dinosaur one.
Yeah, and the
Yeah.
rest.
Putting it in.
Did you say what that code?
Oh, that code is an example of our windmill code.
How does it work?
It has a lot of where it goes forward. We line it up and it goes forward and pushes in the TV very slowly, so that the energy gets put in the back slot, and then it will go back and turn so that it turns and hits the windmill, and then as they fall down, they will collect in this little basket, and we can bring them over to a rechargeable battery to get 5 points per piece.
So you probably already noticed this, but it is a spike robot as opposed to EV3. It's the newer kind, so.
We got to
Any more
experience code with that.
questions?
Who does primarily the programming, or do you kind of share that?
So
Me.
in the beginning, we
me
sort of
and-
split up.
Yeah.
Yeah,
And so
him
Me,
were really the
Bennett,
helpers.
Rowan, Gracie, and Josh. We were the main ones working with the robot at the beginning.
Grace and Rowan both built.
They were more
Both
the
of the robots.
builders.
Yeah, they were the builders.
And then me and Rowan were more of the
Coders.
main coders.
So you have quite a strategy, it sounds like. Has that always been the case? Like, was that always your plan, or did you have to make improvements along the way?
Well, at the beginning, we split it. We figured out which people are better at the best stuff, and then we split them up into groups.
Because originally, we sort of just threw people into the group they thought they worked at, but then over time you could see people sort of shift. Like at the beginning, I was working a good bit with the robot, but slowly I shifted over and started to work on some of that.
Yeah, Bennett was originally a researcher, but
I moved on
he
to
really
robots.
just switched back and forth. He was really good with electronics and he was good with the robot.
And Charlie was a late addition. He came like right after Christmas break.
2 weeks before the competition.
Oh, wow,
And
okay.
he's a really good.
He designed almost
all
every
him.
single one of these.
Okay.
Yeah,
Except for
Char-
this one. This one's not 3D printed.
It's obviously
Obviously.
he was able to come because one of our members, his name was Spiros, he was working with us, but he couldn't make it to the competition, but he still came and tried to help us.
Is there anything else you want to tell us about your robot specifically? Anything that you think is really innovative about it?
We were originally using larger wheels, but now we use smaller wheels because with one rotation with the bigger wheels,
It would
it
get
rotates
more
like twice as much. So whenever you do it with the smaller wheels, they do tend to skip a tiny bit, but it does do the missions a lot better. And we also only have one motor doing this because it's a lot less coding and it's a lot more reliable.
And the useful thing about having one motor is because you are able, it's not multiple motors where when you tell it to do this code, it's not trying to move a bunch of different motors. It's only doing one. That way it's not trying to do multiple tasks.
And it might break it, because if you, even for one tiny code, if you forget to move one motor, it might try to twist itself and it might break it during the competition.
So you went with simple.
Simple.
And how many points do you think you might score today?
The maximum we can get is around 270
Okay.
The
Awesome.
maximum they have gotten, I think, is 260.
to 230.
Wow, very good. That's a
During
high
our
score.
practice
During our
Really
practice round, we
simple.
got 220 or 220.
We got 220 on the practice round.
Okay, very cool.
We did, they did,
We experienced some issues with one of the boards, though.
On
Yeah.
our first round.
It happens, right?
One day.
Anything else about the robot?
no, not really.
Any
No,
questions?
All right, we have a few minutes for core values then.
Okay.
So,
We're gonna start out with impact,
okay.
and that is either broken.
So the order we'll be going is here, 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 here.
Perfect.
Okay, so impact means to me the effect it has on the community. For example, reducing water bills and making energy more portable and available to more people. And it benefits the planet because it's a renewable resource, so it's not affecting global warming or anything like that.
The discovery to me is the fact that we were able to elaborate in such like categories as of renewable energy, like again methane, biomass, many other subjects that we wouldn't have been able to do all together if not for the robotics team, which with the solar panels, which we mentioned briefly in our skit, is we were able to find that we didn't store the energy on our solar panels, but we wanted to do that with our innovative project. And given that, when we got to a stable position in our innovative project, we were able to show that with professionals and get feedback on how to improve on that.
Inclusion to me means that everybody gets to participate in their own way and become a part of a team while helping that same team.
So, you done?
Yeah, I'm done. Just
So to me, innovation means pretty much to create or sort of like discover or add on to something that can be productive and help others. One way we sort of did this was trying to work on building a new battery. We felt like that might stand out, so we had to innovate that.
Our team had a lot of fun during the process of making like all this, like hydroelectric U, the robot. I think the funnest time that I had personally was when we started to fly drones, and we also like got to go onto the roof and like see all the solar panels and stuff. And we also met a lot of people along the way.
To me, teamwork is really important because I was really late to the team. That's because everybody has a very different and unique talent, and mine happens to be 3D modeling and printing, as you can see. And it also has helped me learn that when everybody's different and everybody has their own unique talent, you can achieve a lot.
Okay.
hold
yeah, go
on,
ahead.
one more thing.
Yeah.
So we did talk earlier about our friend Spiros, who
Was late.
he wasn't late. He was not able to come to the competition,
Right.
so he is here in spirit. And Grace had something she wanted to add, right?
Also about I just want to say that my favorite one on the board was teamwork. That I really liked how we got to make new friends and become really close friends, really close friends, and yeah.
And you guys are what grade?
Sixth
Fifth and
and
sixth.
sixth.
Okay, so you're fifth and sixth graders?
We're
Okay.
Intermediate school.
Okay, that's what I thought that meant, but I wanted to make sure. It's hard when you have a team this large at your age to get everybody on the same page and working together. And did you guys ever have any conflict?
In the
Yeah.
beginning, we did have. I chose methane. Somebody he wanted to do the Hoover Dam.
Yeah, I tried to explain to him about methane and how, I tried to politely explain to him how methane is a terrible gas for the environment sometimes. And I tried to get him on track again with other ideas. And eventually he did come up with a really good idea, I think.
A gravitational energy, so there was a ball that would go up and down in a vacuum that would power a machine.
Electric car.
Yeah.
And I thought that was really good. And so,
This is my
We ended up taking
my
the
man.
vote because originally we split up in just the groups or solo, looking at different energy and coming up with ideas. And then we came to a group, talked about our different ideas and presented them, then debated about it. Any questions?
And, go ahead.
And also, I'm gonna add on to Watson about him talking about methane. He even sang a song about it.
He had a
Very
lot of
passionate.
fun.
I was very passionate about methane. One more thing about Spiros. I did like the way that he helped us, even though he knew he wasn't going to be able to contribute to, well, not be able to contribute to the final
He
project.
showed
He
up
did do
until
that.
last Thursday, and he pretty much ever since Christmas break had known I'm not going to be able to make it.
And he helped anyway. He was really good at finding websites that would help us research about the project. And he was just a real help to the team, even though he wasn't able to be here.
Any questions?
Just have one more. Coaches, what kind of impact did your coaches have on you this season?
Oh man.
Huge impact.
Yeah, it really helped us out. So like at the start, like I wasn't really sure about all of this because like I was like excited to be in the robotics team because I wanted to be in the robotics club and I didn't know I could be in the team. And so my judge like informed me that this team is for smart kids and people that are good with technology, and so that really got my hopes up, and so I've done a lot better.
Yeah, I really Miss Smith and Miss Jenny, both of them. So they do a lot for us. They juggle STEM, robotics, tech fair, and hydroponics.
Yeah.
So it's all a big thing for them. Yet they devote so much of their time and energy towards us.
and Miss Jenny also really helped with the robot team, while Miss Smith really helped the research team be able to achieve what we have today.
And also, she really kept us on track. Like,
That's
if falls
important.
off of track, falls off track, she would be like, "Alright, what are you doing? Get back on track."
It's great that you recognize that your coaches had such an impact, and I hope that you shared what you just shared with us with them.
Yes.
Because they need to hear that from you.
I think they'd be really proud.
Yes,
Okay.
they should be. And you guys did a great job, but we are out of time with you. So amazing work. We love spending time with you. But go ahead and grab all your things.
Thank you.
And don't forget your notebook and your prototypes here. Good
I'll
luck the
grab
rest of the
the
day. I hope everything goes well.
You need to grab it. I'll grab the paper. So